Learn theoretically, learn practically only. It means theoretically only or practically only. That's the second choice. The third choice, learn theoretically and what? Practically. Right? So that's what. But again, we give you a warning. Learning electronics, say learning electronics.
Learning electronics.
So learning electronics concepts, so plural, maybe one concept or three or four, on paper. Learning electronics only, concepts only on paper does not help you to solve what? Does not help you to solve a real life problems. To solve real life problems. That's not this article. So it does not help you. It does. First of all, it will be difficult. You won't understand. You won't enjoy. Right? You won't apply. Right? That's the warning that we are giving you. So you must still learn it on paper and use your mind and hand on doing electronics practicals repeatedly. So for example, that doing electronics practical once, it does not mean that it will give you clear understanding, or it will make you to enjoy, or it will make you maybe to apply. You do it once, and then you forgot it once. You forgot it immediately. Are we together? Yes. So this is the key actually, that you have to try to open your mind. Okay, so now I have made actually permanent decisions. I want to do practicals. I want to learn electronically practically. So I just want to open your mind. Maybe you know about that ones, but I want to insist you to know that this is the principle, this is the process. Okay? Because if now you try, for example, to think yourself, imagine that you spend a one semester, which is 4 months, right? Learn what electronics is theoretically. What if you just spend 1 month in these 4 months to learn practically? Where will you be right now? Huh? Kat, where will you be? Where will you be right now? Very far. Huh? Very far. How many kilometers from here? Huh? Okay, is there any question? Is there any question? Is there any question, students? If you have any questions, please ask it. Do you have any question?
No.
Okay, is these introductions clear?
Yes.
Sure?
Yes.
Did you understand it?
Yes.
Will you take an action for it?
Yes.
Okay, good. The second thing, so this is just, it was introductions of fundamental, so just you can number it to 1.0. Then the second thing that I want to build in your mind in these introductions is something, I call it the big picture of electronics engineering. Say the big picture of electronics engineering.
The big picture of electronics.
Huh?
The big picture of electronics.
I say that I don't have Kingdom Protista in this class. Right? I have Kingdom Animalia. Say the big picture of electronics engineering.
The big picture of electronics engineering.
Is that the voice of 6 students or 6 engineers? Again, say the big pictures of electronics engineering.
The big picture of electronics engineering.
Wonderful. I appreciate it now. So whenever you want to learn electronics, whether formally or informal, one thing which I can advise you should have a big picture first. Then from there, once you have a big picture, it will be easy for you to go far. And this big picture will draw it from 2 directions. Firstly, when we've been learning about, or when we began our formal learning or informal learnings, especially at home, we met with something that we call mathematics. You remember mathematics?
Yes.
Huh?
Yes.
We used to meet with concepts of mathematics at home. We didn't even go to the baby care class. Our brothers or our sisters, they used to teach us to count. Say 1. Say 1. Moja. Moja. Every day. Whenever he or she comes back from school, okay, sema moja, 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 moja. You don't know how moja does that look like. But then up to 1 to 5, right? Then 1 to 10. So you find some kids, they can count 1 to 100 while they didn't go even to the baby care school. That is mathematics. the beginnings of the journey of mathematics. But now you're in college, you're in university. So you've been studying about mathematics, but did you think about why were you learning about it? How did you use it? Okay, so we have these subjects of mathematics. With these subjects of mathematics, once we've been in in standard 3, we met again with another subject that's called the science. Do you remember science?
Yes.
Do you remember science?
Yes.
In our Tanzanian educational system, we used to start learning, I think, standard 3. Huh? Huh? Or you don't? Standard 3 or standard 5? 5? Ah, standard 3, you forgot. For me, I did my standard 3 in 1993, 1994. But I still remember that I had science. You, who did it a few years ago, you don't remember it. Why? Because you passed the exam. Wonderful. Okay, so in this mathematics, okay, so maybe in primary education, so whatever, we've been going with it. But okay, so then we said that, okay, so we have here our friend science. So once we went into secondary education, these subjects of science, especially O level, it has been divided into 3 subjects. Remember them? Huh?
Yes.
Then we have what? We had the physics, we had the biology, we had the chemistry. Right? This is a big picture. You've been learning electronics from science, from standard 3. But you've been learning it invisibly. But once that in these subjects of physics, okay, so this is for O level, you can study also physics in A level, right? So in A level, you can find about 30 advanced physics for those who used to go for A level. But also in diploma, you can find maybe applied physics. You learn about gravitation, you learn about statics and dynamics. That's applied physics. Okay? Are we together?
Yes.
So, including applied physics, the combination of applied physics and advanced physics, here we get something called electronics. Are we together? Are we together?
Yes.
We get something that we call electrons. However, that electrons is the one with the topic of physics for the Form 4. But actually, that you find that now, once you accomplish this applied physics or advanced physics, then you can find that now the field of electrons, it can stand itself. Are we together?
Yes.
Are we together?
Yes.
When we come with this mathematics, or we've been navigating with this mathematics, in primary school we used to learn mathematics, only mathematics and mathematics. But once we are in secondary education, we meet with 2 branches, 2 subjects of mathematics. Basic mathematics, or basic math, and then we have what? Additional mathematics. Okay? Are you together?
Yes.
There you've been building something, we've been building step to step that can help you to learn electronics. Are we together? So we had the long project of teaching you electronics since at home. But unfortunately, the person who has been the main character of the journey of learning, he or she didn't know that, because that I was learning about electronics. Then, when he or she meet with electronics, then she saw that this electronics is new, it's come from heaven. Do you understand what am I saying? So most of these subjects, either you study additional, because this is the optional, this is the compulsory for every Tanzanian, whether you like or don't like, and we used to call it Olenjolai. Right? Once we graduate there, which is O level actual, with certificate secondary education examination, we have 2 routes. Whether we can go ordinary diploma, whether sometimes if we didn't do well, we can go to certificate, right? Or we can go to A level education. Are you together? Are you together? So whether in ordinary diploma or certificates or whatever, these 3 branches or big pictures of mathematics, they just give you 2 branches of mathematics. The first one is pure mathematics. So you find here pure mathematics. And the second one is applied mathematics. Applied what? Applied mathematics. Are we together? I don't know if you understand. This is the way I used to learn this stuff. I'm trying to change your mindset. So what are we looking in that big picture? We're looking at our best friend electronics. Where is he? Or where did it come from? Are we together? So, okay, so here we have found the electronics either from applied physics or from advanced physics. Okay, that's the point, because we have a topic of electronics there and advanced physics, but later, so once we graduate or we pass the exam, so we understand advanced physics and applied physics, now electronics, it can be now as a broad branch, right? And you can navigate on electronics and forget about mechanics, forget about civil, forget about all other fields and focus on electronics. Are we together?
Yes.
Again, so then what is our interest or the aim of us of teaching or of Tanzania educational systems to teach you about mathematics? Why you don't need to be a mathematician. The aim is we want to teach you and prepare you to understand about applied mathematics. Are we together?
Yes.
So in this applied mathematics, there are so many branches. You can find applied mathematics in economics. Okay, you can find applied mathematics in business. You see now the big picture, eh? In business, you can find applied mathematics in computer or in software, right? But now you can find applied mathematics in engineering. You know what? Keep on listening and think in engineering. Right? All of this, we apply mathematics, can apply mathematics in economics, can apply mathematics in business, can apply mathematics in software design, can apply mathematics in engineering, etc., etc., etc. It doesn't mean that these are the 4 branches or areas that we have you can apply mathematics. We have so many branches. Right? One of the branches is engineering. But again, engineering is broad term. It's actually a huge term. Right? In engineering, okay, so we say that, okay, fine. Wonderful. So even, I think that, so I think that, okay, let's do minor correction here. You have to write this stuff. Don't think, because I told you yesterday, actual engineering, engineering is art. Sometimes you can write some issues or some stuff, other people, they find that you are crazy. But that's how you are designing something new. Or that's how you can implement something new. Because it's just like you're drawing. For example, now if you meet an architect, maybe drawing maybe a particular tall buildings of maybe 10 floors, because you don't understand, and then you find that he has spent 5 years drawing, and then these are the drawings. So what's the meaning of this? Then he just tell you that you don't know how beautiful it is. Similar to engineering. Sometimes you can find that people, they cannot understand that what you are saying, what you are doing. But just you can ask them, give me some time. You'll understand me practically. Are we together? So here it means in the applied physics and the advanced physics, because I have some students here who have come from advanced physics, right? So actually here, before you meet electronics, before you meet electronics, you still have science as usual, right? But again, you find another field that we call engineering. Right? So here you see that the big picture of science up to engineering. You see that the big picture of mathematics up to engineering, mathematics. Are we together? Yes. This is what we call engineering, mathematics. So you can say that here we find out engineering, mathematics. So now, in our big picture, we have what? We have engineering, okay, plus what? Engineering, because that you cannot learn engineering without mathematics. Engineering what? Mathematics. Are we together? So you have engineering from science, and you have engineering mathematics from mathematics. But we have different branches of engineering. So it means that here you can have either, for me, I used to categorize all the branches of engineering into 2 branches of engineering. Very interesting to me. I used to sit down and think about what has been designed by this field of engineering, this field, and then finally categorize them into 2 branches. My dear students, in the world we have 2 types of engineering. We have visible engineering and invisible engineering. What it means of visible engineering, that everything which is being done or is being built or is being implemented or designed is visible by our naked eyes. But also there's another field of engineering where things are working but you don't see them by your naked eyes. Are we together?
Yes.
Okay, so here it means that we have what? Visible engineering. So this visible engineering also, you find that it has particular applied mathematics, but also you have what? Invisible engineering. So visible engineering but plus what? Applied math. And here we have visible engineering plus what? Applied what? Applied math. So there is a particular applied mathematics is for visible engineering. And there's particular applied mathematics for the invisible engineering. But students asking, sir, what do you mean about visible engineering? Well, so let us continue with our big picture. So this is the big picture. Tell your neighbor that we are learning about big picture. I said you are not Kingdom Moti, Plantai. You are Kingdom Moti? Hey, yes. So you have to speak as Kingdom and Maria. So tell your neighbor that you are learning the big picture of electronics.
We are learning the big picture of electronics.
Are you satisfied with your voice? Do you used to hear yourself? For example, Adrian here. Hey. Okay, so you have visible engineering and invisible engineering. Okay, before I go inside the invisible engineering where electronics is, so examples of visible engineering are civil engineering. Why civil engineering? Have you ever find that a civil engineer building an invisible house? Or have you ever find a civil engineer building an invisible bridge? Alafu jamani, ndugu zangu sikilizeni, mchore haya, yani haya mnapochora chora hivi ndio ufundi wenyewe unavyoenda. Yaani ufundi sometimes sio kama maelezo. Ufundi ni michoro hii. Na unaweza kuona saizi kama sasa wanapoteza muda, sina nikashika. Wewe chora tu hivyo. Hata baadaye ukiona tatizo, unachora vitu ambavyo wewe mwenyewe sometimes uelewi, lakini ndo unaelewa. Na represent idea yako. Sawa? Ndio maana mimi nachora, nikiweza kuandika maelezo. Na usichore tu ndio unachora. Chora ukiwa unaelewa kwamba hapa ni kitu fulani, hapa ni kitu fulani, hapa ni kitu fulani. So the good example of visible engineering is civil. Another good example of because most of the civil engineering systems are visible. Do you agree?
Yes. Yes.
Is a bridge visible?
Yes.
Now, for example, if you are building in case of water pipes, are water pipes visible or invisible?
Visible.
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 Visible. Okay, for transportation, let's say for example for the flyover roads, are they visible or invisible?
Visible.
Yeah. Another example for visible engineering, mechanical
Engineering.
Mechanical engineering. Why mechanical engineering? For example of mechanical system, a car. Is a car invisible or visible?
Visible.
Visible, right? Another example of mechanical system or a system which is built by mechanical engineers? Generator. Generator it is, okay, yeah, generator it has mechanical parts and electrical parts. Is a generator visible or invisible?
Visible.
Visible. Another example, electric, for example, another example is train, right? Is train visible or invisible?
Visible.
Another example is airplane. Are the airplanes visible or invisible?
Visible. Visible.
Except it's also of the spiritual. In the spiritual world. Have you ever heard them?
No.
No. Huh? Okay. Another example of physical engineering, mining, right? Huh? Yes, mining. Mining. So it means that all the mines are visible. Huh? Have you ever seen that invisible diamond? No. So, etc., etc., etc. Once we come to the invisible engineering now, first of all, we meet with the mother of invisible engineering, which is what? Electrical engineering. So, electrical engineering is actual what we call it the mother of invisible, or I call it the mother of invisible engineering. Guys, remember that also in engineering we used to call mathematics as queen of engineering. Mathematics is the queen of what?
Engineering.
So if engineering, so if mathematics is a queen, then engineering is what? It's a king. Yeah. So you see that now you're building something new, eh? Eh? Rather than just thinking about test 1 and test 2 and assignment. Okay. So here it means that we have electrical engineering. Then now this electrical engineering, it has different branches. One of the branch is electronics engineering. This is invisible. Why we call them invisible? Have you ever seen electrical by your naked eyes? No, electrons. Have you ever seen the electrons by your naked eyes?
No.
Have you ever seen the hole in semiconductors by your naked eyes?
No.
Have you ever seen maybe the sound signal transmitted by the mobile phones from Mwanza to Dar es Salaam when you are talking to your father or mother? You don't see, but they are working. Huh?
Yes.
Have you ever seen maybe the sound, the video, right? The picture from TBC production coming physical and get into your television set, receiver set? No. But it's working, it is there. Once you turn it, you get the signal, you have good connection, then you receive the picture. Are we together?
Yes.
Are we together?
Yes.
But it's invisible by your naked eyes. Wonderful. But it's working and it's there. For example, for electrical, if you want to test it, you just be a part of the circuit. Then you understand whether electricity is there or it's not there. Have you ever tried?
Yes.
What happened? You left the place. And even if you've been cleaning, then you stop. You don't want to touch that place again.
Yes.
Why? Because electricity is there, but it is invisible.
Sir,
Yes.
I have a question.
Yes. You're welcome.
If electric engineering is invisible engineering, there is a possible that you can charge a phone.
Wireless.
Wireless.
Yes, there are wireless chargers right nowadays. There are working wireless chargers. The transmitter, you just connect it in the socket, and then maybe you find that a receiver, you connect it in your mobile phone, but maybe you have your mobile phone, you're using it while it is being charged there on the socket.
So we can transport electrically from one place to another.
Wireless. Yeah, it is possible. For example, that if you say, for example, that you are here, Isaiah, in Dar es Salaam, and then you are communicating with your brother who is in Rukwa, right? That is sound signal. When you talk, this is the sound signal, right? But this sound signal is being embedded in a carrier wave, which is electromagnetic signal. And we call it electromagnetic signal, it means it has electrical and magnetic properties. And that embedded signal, which is information signal, and carrier signal, are the one which are being transmitted from Magomeni Mapipa to Rukwa. Right? Once it reaches there in the receiver mobile handset, then the information is being demodulated, where the carrier wave is being suppressed, and the information signal, which is a sound now, will be converted from electric form into sound form by using the speaker of the receiving mobile handset. Did you understand?
Yes.
But once I know your questions is, okay, that is low power electric signal transmission. You're asking about how about high power electric signal transmissions. That's what I told you, according to the current technology. Before it was a very challenging to transmit wirelessly the high power electric energy. But nowadays, according to the technology and the investments, is possible, but not for the long distance. Okay?
Yes.
Are we together? Are we together?
Yes.
Okay, so here one of the branches is what? Electronics engineering. Another branch is what? Computer engineering. Computer what? Engineering. Computer engineering. Then another one, even biomedical engineering in most parts, away from those mechanical parts. Okay, mechanical parts. Then another branch is what? The
Software engineer.
software engineering. Ah, no. No, we're not focusing on that. We're not focusing on software engineering. Yeah, okay. Software engineering is also a branch of what?